So today we're looking into how to write and balance a chemical equation. Okay, so a couple different things we need to keep in mind when we're talking about chemical equations. There are multiple pieces to one. Let's write one down and break it apart. This one, Fe plus S yields FeS. So if we want to go back to our bonding and naming unit, that's iron. This is sulfur, and this would be iron, figure out the charge, iron 2 sulfide. Now, all of that is, kind of superfluous to what we're doing right now, because what we're doing right now is balancing. All right, what does balancing mean? It means we need the same number of atoms of each kind on both sides of the equation. What I like to do to help me out is draw it. So, one single iron, this tells us that we got one single sulfur, and the fact that we just have FeS means that we have Fe bonded to S. Alright, so we can keep an accounting of it here. We have one sulfur, one iron. Over on here, we have one iron and one sulfur. So if we were to draw out or write out our coefficients, the number that goes in front of each species here, each coefficient would be 1. This one balances without us having to do anything weird. But as we go forward, let's try and see some ones that don't actually work that easily. The next one we'll do is this. HgO yields Hg plus O2. Remember, whenever we see oxygen listed by itself, it is going to be a diatomic. And this is mercury, this is mercury 2 oxide. Okay, so we can identify this right here. Let's go ahead and draw out. This is an Hg bonded to an O. This is Hg, and this is O bonded to O. Now, we're not going to be too careful about our Lewis structure. If you wanted to draw this out as a full Lewis structure, you can. It doesn't really add much to it, though. All right, so just for clarity's sake. Well, what we're trying to do is end up with the same number of oxygens on left and right, same number of mercuries on left and right. We've got subscript here telling us that for each group of oxygen, I have 2 oxygen atoms. The no subscripts over here tell me that I've just got 1 and 1 of each one. Now, the subscript will tell us that every time I change the number of oxygen groups, I need to add 2 of them at the same time. All right, I can't just decide to tack on an extra oxygen right here. That doesn't work. What we notice right now is that my mercury, there is 1 of them, and my oxygen, there's 1 of them. Mercury over here, there's 1, oxygen, there's 2. Well, obviously this is a problem. I need another oxygen. I also can't decide just to add another oxygen, so to get another one, I've got to use an entire new unit of HgO. Now, that's changing. I've got 2 of these, and I've got 2 of these. 2 mercury, 2 oxygen. On this side, still 2 oxygen, still 1 mercury. Well, I need 2 of them to balance. I've got 2 mercury, 2 oxygen, 2 oxygen. The coefficient is just going to be how many of these did I draw on each side. I've got 1, 2 groups that look the same, so that coefficient's a 2. I've got 1, 2 groups that look the same. I've got 1 group that looks the same, so our coefficients would be 2, 2, and 1. Take a look at our next one. N2 plus H2 yields NH3. We have nitrogen plus hydrogen gives you ammonia. Okay, so once again, let's draw this out. We've got nitrogen, we've got hydrogen, and we've got NH3. Okay. Well, so again, these subscripts tell us how many of that type of atom are in each group. N2 just means 2 nitrogens. NH3 means 1 nitrogen and 3 hydrogens. Okay, just like our formula shows us. Well, here we have a choice, because our nitrogens, we've got 2 on this side and we've got 1 on that side. Our hydrogens, we've got 2 on this side and we've got 3 on that side. Neither one of those match up. So we get to pick which one we fix first. Doesn't really matter, since they're all going to end up the same anyway. Okay? So let's try fixing the hydrogens first. I cannot decide to just add another hydrogen here. I have to add an H2 group. Now, I have 4 hydrogen atoms, 1, 2, 3, 4, which, is now more than 3. Problem is, we need to be equal. So let's go ahead and add another group of NH3. Again, I can't just decide to add an H. If I want more hydrogens on this side, I need to add a whole nother NH3 unit. Alright, so now I have 2 whole groups of NH3. 1, 2, 3 hydrogens, 1, 2, 3, put it together, that's 6. I also have changed the number of nitrogens. I've got 2 of them. Well, nitrogens match, but hydrogens don't. I've got 6 and I've got 4. Fortunately, the only way I can add more hydrogens is 2 at a time. So, I've got 1 N2, 3 H2, and 2 NH3. Aluminum plus oxygen yields aluminum oxide. We've got Al, and I'll just put it out like that. For this one, it doesn't really matter how they're connected. We just need to make sure that we've got 2 aluminums and 3 oxygens. Your oxygen here, and your aluminum. So here, aluminum on one side, 1, on the other is 2. O, on this side is 2, on this side is 3. Well, let's figure out what we want to fix first. I'd say let's fix our oxygens first. Okay? Well, we've got 3 of them over here, we got 2 of them over here, so very similar to the last one, we can add another oxygen. Alright, another O2. Well, then we have 4 and 3, so let's add another group of what we just had over there. Well, now we have 1, 2, 3, 4, 5, 6 oxygens. 1, 2, 3, 4 aluminums. Okay. We've got 6 oxygens here, we've got 4 oxygens over here, so we need to add another group of O2s. And there's your 6. Well, here's the trouble now, is that we've got 4 aluminums and only 1 over here. So we need to add more aluminums until we get to 4 of them. We've got 4 of those, we've got 3 of these, and we've got 2 of those. Okay. This one's very similar to one we saw as an example. H2O, this is the decomposition of water into its constituent elements. So we've got H2O, always like to draw water as bent, H2, O2. H on either side, we've got 2 and 2, oxygen on either side, we've got 1 and 2. So let's fix our oxygens first. To add another oxygen, I need to have another whole water molecule. I can't decide to just add an oxygen or add a hydrogen. So I've got 2 of those, and now I've got 4 hydrogens. Okay. On this side, 2 oxygens, 4 hydrogens, 2 hydrogens. So we need another set. Now I've got 1, we check, 4 hydrogens, good, 4 and 4, 2 and 2, we're all set. I've got 1 O2, I've got 2 H2, and I've got 2 H2O. So that's 5 down so far. Let's look at our next one. Phosphorus plus oxygen yields diphosphorus pentoxide. Now, this is a little bit of a strange one. So basically got 2 phosphorus. Really any way you want to draw this. It's up to you. As long as there's 2 phosphorus and 5 oxygen, it doesn't really matter what the way it looks. Alright, so we've got an O and we've got a P. Alright, so 2 on that side, 1 on this side. We've got 5 and 2. So let's fix our oxygens first. Okay, so to get up to 5, well, we can add another O, then we have 4. Still not enough. Alright, still not enough on this side. So let's add another one. And we get up to 6 oxygens. But now we have more of those. So let's add another set just like we had. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. We've got 1, 2, 3, 4 phosphorus. Well, to get up to 10 oxygens, I need to have 5 groups of those. 1, 2, 3, 4, 5 times 2 gives you 10. And I also need 4 of these. So I have 4 phosphorus, I have 5 O2, and I have 2 P2O5. Okay. Again, don't really worry about how the drawing works. As long as you have all the atoms that you say that your formula says you do, it doesn't really matter how they're connected or what their order is. Iron plus water yields hydrogen plus iron 3 oxide. Okay, so we have actually 3 atoms to keep track of here: iron, hydrogen, and oxygen. So we have a choice. Let's fix the oxygens first. If I've got 3 over here, oh, excuse me, let's go ahead and draw. Okay. Ooh, that went a little bit off the board. There we go. Should be okay. Let's fix our oxygens first. I've got 3 of them over here. I've only got 1 here, so to get another oxygen, I need to add another water. Still not enough. I need to add another water. Now I have 3 oxygens. I have 1, 2, 3, 4, 5, 6 hydrogens, and so far still just same on the other side. Oxygens are good. Hydrogens, 6 and 2. Well, if I add that, then I've got 4. If I add that, then I've got 6. Hydrogens are good. All I would need to do here, 2 irons, now 2 irons. So I've got 2 of those, I've got 3 of these, I've got 3 of these, and only 1 of those. Okay. Do a couple more, and then we'll leave some of these for you to practice with. Alright, so again, we get iron 2 oxide, iron 3 oxide, excuse me, Fe2O3, plus carbon gives you iron and carbon monoxide. This is actually a reaction that's used in blast furnaces and smelters when you're making steel. You take oxidized iron, iron ore, react it with coke, charcoal, like very, very pure carbon. The carbon will react with the oxygen, leaving you just the iron. This gets melted and poured out. Okay, so draw down. Again, doesn't really matter what the drawings look like, just as long as they've got every atom in there. Alright, and on this side you've got 2 irons, on this side you've got 1. Oxygen, you've got 3, on this side you've got 1. Carbon is 1 and 1. So, go ahead and add some more of these guys. 3 oxygens, 1 oxygen, that's going to be our first priority. To add more oxygens, we need to add more COs. Alright, so 1, 2, 3. We've got, oops, excuse me, we're not going to do that yet. Alright, but now we have 3 carbons and 3 oxygens. Over on this side, to balance out our carbons, we need to add more carbons. Alright, so we have 3 carbons now. And since we've got 2 irons, 1 iron, we just add a second one. So far, so good. If you look at the number, we've got 1 of those, we've got 3 of those, we've got 2 of those, and we've got 3 of those. Okay. So that's a total of 8 of these. We're going to do 1 more with this, we'll do 2 more drawing all these things out. Alright, and then we'll go ahead and see if we can't do a little bit quicker method next time. So, we've got CO2, carbon dioxide, plus water yields H2CO3. Carbon dioxide and water gives you carbonic acid. It's actually the way that they carbonate sodas. All right, they push carbon dioxide into water, and it'll actually make an acidic solution. So we've got carbon dioxide, we've got water, and we've got H2CO3. Again, don't worry about how it's drawn. All right, just as long as you include 2 H's, CO3. That's all good. Okay. So you've got your carbon. You've got 1 over here. You've got 1 over here. Oxygen. You've got 2, 3 over here, and over here you got 1, 2, 3. Hydrogen. You've got 2 over here, and you've got 2 over here. Well, what do you know? 1 carbon, 3 oxygen, 2 hydrogens. It's the same all across the board. All right, just one of those apiece. One more with the drawing, and then we'll move into a quicker way to do these. We're actually going to skip ahead. If you're following along with the worksheet, we're actually going to skip ahead here and try one of the trickier ones that doesn't involve, or that will involve doing some more drawing here. So let's skip down to, again, if you're following, number 12 on the worksheet. Ki plus Pb NO3 2 gives you Pb I2 plus KNO3. Okay, so here we've got K bonded to I. Here we've got a Pb, and there's actually two groups of NO3. So there's one NO3. Here's another NO3. Okay, so one lead and then two NO3s. Here's a Pb with an I on either side. Here's a K bonded to NO3. Okay, so lots of drawing. All right, this one probably takes a little bit of time. And we actually have 4 different atoms that we're going to be keeping track of. We've got potassium, one of those, and one of those. We've got iodine. I've got one of those, and I've got 2 of those. I've got Pb, I've got 1 and 1. Now the other thing we're going to keep track of is actually NO3. We're going to keep track of NO3 as a unit. If you have a polyatomic ion, like nitrate, okay, if you have a polyatomic ion like nitrate, and you see the same polyatomic ion on the other side, it means you can keep it together. You don't need to worry about splitting it up into its constituent atoms. All right, so since we have nitrate on both sides here, we can just treat it like it's a unit and keep it together. I have 1, 2 nitrates on this side, and on this side I have 1. So that looks like one of the problems is going to be my nitrates. Let's fix that first. So I'm going to need another nitrate. Okay. Now I have 2 nitrates on that side. Okay. The other thing I'll need to fix is the iodines. 1, 2, and I've only got 1. So add another one of those guys. Now, see, here's the issue, is I've added 2 potassiums, which I go over here and look, ooh, I forgot to update it. 1, 2 potassiums. So it's always make sure that you've gone back and you've updated every single thing after you make a change like that. Now we have 2 and 2, 2 and 2, 1 and 1, 2 and 2. We have 2 of those. Ooh, can't see that. Let me subscript, or that's your coefficient. 2 of those, 1 of those, 1 of those, and 2 of those. Okay. So that should be it for the drawing part of it. What we're going to do is go back and look at a couple simpler ways of doing this with a little bit more math. So back up to number 10. Zinc plus copper tooth sulfate yields zinc sulfate and copper. Well, here we're just going to keep track of the fact that we have 1 zinc on this side, 1 zinc here, copper, 1 copper, 1 copper, and then SO4, since it's on both sides, we've actually just got 1 and got 1. How do we know that we don't have 4 of these things? Because it's a polyatomic ion, and there are no parentheses. No parentheses means I only have 1 of these units. So I've got 1, 1, 1, and 1. All right, coefficients stay 1. You're also going to notice that coefficients for number 11 should also stay all 1, since you've got the same number of each type of atom on either side. Skip right to number 13 if you're following along. Magnesium chloride plus NH4NO3, ammonium nitrate, gives you magnesium nitrate plus NH4Cl, ammonium chloride. So, you've got magnesium, where we've got 1 of them here. We've got 1 of them here. Chlorine, we've got 1 of them here, 2 of them here, and 1 of them here. NH4, check. Does it appear on both sides? We see it here. We see it here. Okay, 1 and 1. And again, no parentheses, so there's only one of that type of atom, or type of ion, excuse me. Nitrate is here and here. One of these, and we actually have 2 nitrates there. So, let's fix up some things. I've got 2 chlorines, I've got 1 chlorine. So, let's add another one of those guys, okay? Let's put a 2 in front of there. That should be a coefficient, but I'm kind of running out of space. What that means is now I've got 2 ammoniums, and I've got 2 chlorides. Well, since that changed my number of ammoniums, and I need to fix my number of nitrates as well, why don't we stick a 2 in front of here? Okay, so we've got 2 of those, and now we've got 2 of those. 2 of everything that's inside here. Okay, and then we're actually, it works out. Okay, when we draw what this looks like, okay, we've got an NH4 and an NO3. Well, and the fact that we've got a coefficient there says we have 2 of each of them. So if we count all the types up, we're okay. Mg bonded to an NO3 on either side. And I only have 1 entire unit of that. Here, we've got 2 NH4s. And so we end up with equal numbers of compounds on either side. 2 chlorines, 2 chlorines, 2 ammoniums, 2 ammoniums, 2 nitrates, 2 nitrates, and magnesiums. Okay? When you get to the polyatomics, the drawing gets to be a little bit tedious, so this is more when we tend to work on just math and looking at the number of atoms on each side. So, iron 3 chloride plus ammonium hydroxide gives you iron 3 hydroxide plus ammonium chloride again. Well, let's keep track. Iron, you've got 1 and you've got 1. Chlorine, you've got 3 and you've got 1. Ammonium, since you do see it on both sides, you've got 1 and you've got 1. And then hydroxide, you see it on both sides. You've got 1 and you've got 3. So, what do we do first? Let's fix up our hydroxides, why don't we? I've got 3 over here, I've only got 1 here, so let's stick a 3 in front of there. That means now I have 3 groups of ammonium, and I've got 3 groups of hydroxide. Well, it fixes our problem with ammonium, creates a new one with hydroxide. I've got 3 of them now, I want 3 of them on this side. So that means I've also got 3 ammoniums, I've also got 3 chlorines, which actually fixes everything. So in terms of coefficients, we've got 1 here, scoot that over, we've got 3 of these, 1 of those, and 3 of these. Last one. Aluminum plus H2SO4 sulfuric acid, giving you Al2SO4 plus H2. Let's break it all down. We've got aluminum, 1 of them on here, 2 of them on this side. Hydrogen, I've got 2 of them over here, 2 of them over here. And then SO4, 1 of them over here, 3 of them there. So let's try this with the sulfate first. Alright, 3 of them here, only 1 of them here, so stick a 3 in front of that. Means now I've got 3 sulfates and I've also got 6 hydrogens. 6 hydrogens? Well, I need groups of 2, so to get 6 I need 3 groups of 2. That becomes a 6 as well. I've got 2 aluminums, so I'm just going to stick that there. Alright, so now everything matches up and we are all set. That's the first 15 off of our first page. Look for a pen cast for the back side of this page.